All right, so we're continuing our notes where you guys had to create your own headline. So last week on Thursday we started 1B.9. We did part 1 with example 1 and we talked about the snowfalls, right? And now we are on 1B.9 part 2 where we were talking about the Super Bowl data that was given to us, correct? So we discussed and started off with our hook of we reiterate, I'm sorry, what average rate of change means. And when we talk about average rate of change, we are essentially asking you to find your slope of a non-linear function or model. Does that make sense? We just can't call it slope because slope only pertains to linear functions, okay? So anytime it's not a linear function, then you're essentially you're still finding the slope, but just not of that. Okay. All right. So that's when I said that's why on your quiz it was making sure you understood what it meant to evaluate, right? Using function notation. So you guys had to come up with your headlines, and we talked about the headlines to get people to click for the 5 or 10 year. The reason why we lead into this with average rate of change is that depending on what interval you're looking at and analyzing, the story can be different, right? Of what's taking place and what took place. Okay. So we're now on part 2 of your notes. So part 2 of your Super Bowl notes. And again, you can kind of just follow along right now and wait to fill in on your own if you just kind of want to get a gist of what we're going through. You just need to have it done and complete it by your notebook check next Thursday, okay? So up here we have the graph, and it says, how does the choice of interval affect the story told about a scenario? So when we read everyone's story, even though most of you chose the same interval, for the ones who chose differently, it changed whether it was a positive thing, right? Their headline was either a positive headline or a negative headline. That's in general how a lot of people take data. Depending on what part of the data they choose, the story that comes from that may or may not be good or bad, right? That's why it's best to give as much overall data as possible so that you can be true and forthcoming with all your information. So the average rate of change depends on the interval that you're calculating. Over different intervals, your average rate of change might be different. There a reader made completely different impressions scenarios based on the interval, which is what I just said we did. All right, then it says, what was the average rate of change in the Super Bowl viewership from 1990 to 2019? Is this a good representation of change in ownership? So essentially, you're asking if I was to draw a diagonal line connecting from here to here, what would be its average rate of change, right? Just by looking at where that average rate of change would be drawn, would that be a good estimate? No, it's way below my data, right? So like visually, me trying to say, okay, well, before I even do the math, I can visually see that this would not be a good representation of my data. So then you would do the math. Once you do the math, that means you're choosing your 2 points. In order to do average rate of change, you have to have a beginning and a ending, right? If you don't have a beginning and an ending, you cannot find the change in your y over the change in your x. So finding those values, I end up with 0.839 million people. So 0.839 million people on average watch the Super Bowl. That's clearly an underestimate, right? 839,000 is an underestimate of how many people are actually watching Super Bowl. Okay. And so this would not be a fair estimation. But again, could you visually see that connecting from that point to that point would cause it to be below your data, right? The next part is asking over what 1 year interval did the viewership appear to be the greatest positive change? So if I'm looking for the greatest positive change, what should I be looking for visually in my graph? An incline, a very steep incline, right? So I'm looking for a steep incline. So when I'm looking through my data, I'm going to decide where is there a very steep incline. Well, when I look right here, I'm kind of like, okay, here to here is pretty steep, right? Here to here, oh, that's real steep. Are there any other steeper inclines than that? I'm like, no. So I look and I'm like, 1995 to 1996 is a pretty steep incline, correct? So I'm going to say 1995 to 1996. Then it says, over what 1 year interval did the viewership appear to have the greatest negative change? So if I'm looking for a negative change, what am I looking for? the opposite of decline, right? A steep decline. So now I'm going to go through and look for a steep decline. Well, this was, that one's okay. I keep going, I keep going, I keep going. Well, this is pretty steep. From 2017 to 2018, this is a pretty steep incline, right? Once I identify those points, I then am going to use average rate of change to figure out, was it positive or negative? Does that make sense? So when it's all said and done, I come to the conclusion, 1995 to 1996, there was an increase over 10 million viewers tuned in 1990 over that time period. That was the rate. And then 2019, after visually seeing how steep the decline was, it actually decreased by 8 million viewers. Okay. On the next part of my notes, I have no clue why it split I don't know what I did. I pressed enter probably. And the PowerPoint automatically split my question 5 into 5 and 6, but it's still question 5. It's just been split. Okay. So up next, we have here, it says over the 5-year interval indicated the markings on the horizontal axis, did the viewership appear to have the greatest positive change, right? So over a 5-year period, not a 1-year period, where does it look like or appear that we have the greatest viewership change? Okay, this actually kind of goes along with what you guys made for your headlines. A lot of you chose 2005 to 2010 for your headline piece. That's because, honestly, if you look at 2005 and you look up to 2010, pretty much every piece of this interval is increasing, correct? Some are faster than the others, but overall, from 2005 to 2010, there's a pretty steep increase in our viewership, correct? Once I figure out that I'm using 2005 and 2010, I then am just finding the change in my Y over the change in my X, correct? And then so I get an estimated 20 million viewers as my AROC. Okay, then it said over what 5-year interval indicated by the markings of the horizontal axis did the viewership appear to have the greatest negative change. So now you're looking for a piece of the graph where there's a good amount of decline in a 5-year window. Okay, so I'll give you a moment, look at it. Where do you think there is a 5-year window of decline? What'd you say? So we have 2015 to 2020. 2020 is not on there. We stop at 2019. So we're saying from 2014 to 2019. Do the math. What is the decline? Or is it a decline? So if you choose 2014, I would say 2014 is roughly at 112-ish, right? 112.5, 113. And 2019 is at 98.2. So you justify by showing whether it's a positive or negative. Does that make sense? That's how you support what you're saying. So what'd you get? Do you know what you're doing? Do you know what's being asked of you? Do you know what you should be writing down? Do you know what you should be looking at? Okay. Positive or negative? So you got a positive. Okay. So if you're a person who isn't trying to type or write something in, that means you probably should be asking me a question for clarification. So if you're not trying to write or type anything before I start writing anything, that means you have some type of point of confusion and you should voice that. Okay. So all I've asked you right now is to, you guys said that from 2014. So right now, this is 2015. So this would be 2014. So choosing the value of 2014, halfway between 110 and 115 would be 112.5, right? So I'm at 2014, 112.5. And you all are saying from here to here is a drop in the 5-year window, and that would be the steepest. So I'm using these values and these values to find my change in my y over my change in my x. That's all that's being asked for you to do, is to subtract and divide. That is all the math that is taking place. And I'm not even asking you to do it in your head. You can pull up technology to subtract and divide all day long. What I'm measuring you on is your ability to understand what we're doing. So if I'm starting, my Y2 will be 98.2. 98.2 minus my Y1, which is at 112.5, divided by 2019. Sorry, I forgot my parentheses. I had to protect my fractions, numerator and denominator. 2019 minus 2014. Because that's literally all you're doing with average rate of change. I hit enter, and I get negative 2.86. So there's over a 2.87 million decline, right? Does that make sense? Okay, that is what you're doing. That's how you prove whether it's a positive or negative decline. So in previous classes, they chose 2000 to 2005. So they chose to use 2000, which is at about 88 million, to 2005, which is at about 86 million, right? And so following what they did, I would have had 86 minus 88 divided by 5. And theirs is not quite as steep. Does that make sense? Okay. So how you model and determine this depends on what you're choosing. It just says appear to you. The grade is negative. So appearing to you, as long as you're showing your work, is justifying. So I'm going to show you that because a student was like, oh, miss, I think that's the answer. Guess what? And they justified it. I accept it. I'm like, okay, cool. Obviously their math was off because I don't know how they got 2 million. And I don't know why I wrote it without checking it. But you don't want to kill the spirit all the time. So I'm going to go with that. But obviously they were wrong. But you can now see why and prove why they're wrong. Does that make sense? You have the ability to say, oh, that doesn't make sense. So does this make sense as when someone turned in to me from 2000 to 2005, the viewership decreased about 2 million. Okay. What did they do? Well, what they did was they didn't account for it being a 5-year interval, did they? They only counted it as a 1-year interval. So we can see where their error was made. So this is an error. It should not have been this. It should have been from 2014 to 2019. And it's a little over, I'm just going to write 2 million plus, right? Okay. That is all you're doing. That's it. That is average rate of change over and over and over and over and over. And I cannot make it any more clear that all you're doing is subtracting and dividing, subtracting and dividing, subtracting and dividing, subtracting and dividing. That is it.